Today we're doing Unit 1, Section 2, talking about quadratic functions. What is another name for quadratic functions? Parabolas. Have you guys heard of the website called Desmos.com? Okay, it is a pretty amazing website, and it's all with graphing. So you should be able to pull it up in your phone or use the internet at home or go to the library. But it's a great way for you to check your graphs, and I'm going to show you how it works today in class, and we'll kind of play around with it so you can see what happens to different functions. So we're talking about parabolas and specifically how they can translate on graphs. So here we have f of x, which is going to represent a quadratic function. And if I were to add c to it, and this kind of even goes back to what we talked about yesterday when we're dealing with lines, what do you think is going to happen to the graph? Very good. It goes up. And when you have a minus c, it's going to go down. Very good. Now in here, when it has x plus c, left. It's always going to be opposite of what's in parentheses. And so when we have x minus c, it's going to end up going very good. Okay. So right now, I'm going to go ahead and show you this website. Here. So this is Desmos.com. Oops. Hold on a second. Sorry. Okay. Can we all see this okay? All right, so you can see I already put in the function y equals x squared. Yes? Okay, so if I take this, and it's really cool because in here I can write taking f of x, and we're just going to make a c value. Oops. So I'm going to go plus 2. And so do you see how it took the red line and shifted it up? And so that's how we know we're adding 2. Okay, it will do the same thing if I subtract 2. Okay, so you can see how the blue one now went below the line. Yes? Okay, so then I'll show you too, if we do plus 2 inside, see how it shifted to the left? And then inside subtract 2, you can see how it shifts to the right. Okay, now if you look at the next part of your notes, it's talking about reflections, and see how it says negative f of x. What do you think will happen if I put in negative f of x? How will it flip? It's going to flip down. So when it's flipping down, and let's see if that is correct, it does. So see how we have negative f of x and the blue one goes down. It's reflecting which way? How do we say it's reflecting? What is that line it's reflecting over? Okay, so it is reflecting over the x-axis. Okay, so you're going to put x-axis in that blank. I'll move my thing here in a second. What do you think is going to happen when you have the negative inside there next to the x? So if the negative on the outside made it reflect off of the x-axis,
the y-axis.
it is. It's off the y-axis. Now, when I change this here, the blue line is now on top of the red line. Why do you think that's the case on this one? So when something is reflecting, so right now we're talking about how it's reflecting off of this y-axis. I forgot that this is touchscreen. So it's reflecting off of the y-axis here. When it's reflecting, it is taking this piece right here and reflecting it over the y, and it's taking this piece right here and reflecting it over the y. So do you see how when it's on the 0, when it's on the y-axis, if it's reflecting over the y-axis, it's just like flipping the curve, so it actually just stays the same. Okay, but if it's at a different point, it'll reflect differently, and we'll see that later on today. So far, does this kind of make sense what we're doing? Yeah? Okay. So again, we just talked about how with reflections, when you have a negative out here, it reflects about the x-axis, and a negative on the inside, it reflects about the y-axis. So when you have a quadratic function, we have y equals ax squared. The value of a determines the width and direction of the parabola. Okay, so width of the parabola. Does anybody, first of all, this one's saying the width of the parabola is something if -1 is less than a is less than 1. What that means is values between -1 and +1. So what values are in between -1 and +1? 0 is, good. What other values? So I don't have a number line in here, but if I have a number line, here's -1, here's 0, here is +1. What values are also in between those two numbers? A half, fractions, decimals, right? And those, so all of the fractions and decimals are less than 1, and they could be positive or negative. Does that make sense? Okay, so let's just go back here to our graph again. And so we have our regular equation, which was f of x squared. And this time I'm going to make this second one, f of x equals, and let's do a fraction, 1/2 x, oops, we're going to do x, and then down here at the bottom, I don't know if you see it, it has that squared button, so that's how I end up making the squared. So red was the original graph. So what happened when I put the blue one in? Is it more narrow or more wide? Wide. Okay, so when you have a fraction, I think it's going to be more wide. So let's change this fraction and let's use like an even smaller fraction, and let's make that like 1/5. And what do you notice happens when it's 1/5? Even more wide. Okay? What do you think is going to happen if it's a number bigger than 1 or bigger than -1? Like, meaning it's going to make it narrower. Very good. So let's just pull this out here and see. There we go. So let's put a 5. So do you see now how when you have a whole number in front, it makes a more narrow graph? Okay. So when it's a value between -1 and 1, we figured out that it's going to be wide. And this is just saying a number larger than 1 that's positive, or a number that is less than -1, which means like a value that's negative, but not a fraction, okay? So narrow. So we're gonna get down here now, start graphing. When you're graphing in our notes, they want us to use inequality notation and also interval notation. So we'll talk about both of those for domain and range. When you're graphing a parabola, you need to know what the vertex is, and you also need to know what the A value is. What is the vertex? Good, like your center. Okay, so right here, this is my vertex, and that vertex, what is that vertex value on that one? Very good. Okay, and looking at this, okay, so it's 0, 0. The A value on this, do you guys know what the A value is?
Axis of symmetry?
No. The A value is always going to be the number in front. So in this case, there's no number in front, so that means my A value is actually 1. And that's, again, telling us our direction and also if it's going to be wide or narrow, okay? If it's just 1, it's just going to be standard size, okay? So where do we think our vertex is going to be on here? Does anybody have a guess? It does have something to do with 3. What did we learn about parentheses? Anything in parentheses ends up being the opposite. So do you see how that's in parentheses? So it's going to be -3. Also, do you notice how in the parentheses there's an x in there? So really, we would end up setting this equal to 0, and we'd find that the x value of your vertex is actually -3. Okay? The y value, whatever's being added at the end, is your y. So is anything being added at the end here? 0. So that is my vertex. What is my a value? So your a value is always in front of your x squared term. Is there any number in front there? No, so it's just going to be 1. Okay, so we're going to go ahead and plot this. We're going to go left, 1, 2, 3, up 0. Now the a value, I want you to always write it as a fraction. So we're going to write that as 1 over 1. And you need to think about this as like rise over run. And so you start at your vertex, and since it's positive, we're going to go up 1 and right 1. And then you're also going to go up 1 and left 1. Because parabolas are symmetrical, okay? And this basically helps us draw our parabola. You can't go more than 1 over 1, okay? So you can only make those 3 points, because it won't continue to work out that way.
So you only make 3 points?
Just 3 points, and then draw your parabola. What do you think your domain will be on this one? Good. So for your inequality notation, you can just write all reals for domain. And then for interval notation, remember we always go smallest to largest. And so the smallest would be -infinity all the way to oops, if I could draw this right now, positive infinity. Okay. Now, it might not look like it, but parabolas, as they curve, they will keep getting bigger and bigger and bigger and bigger. And so they will end up going out to infinity, okay? So your domain on parabolas will always be -infinity to positive infinity, okay? But is this going to hit every value on the y? So if you look at your y-axis, what is the smallest y value that it hits? What is the smallest y value? What is this value on the y right here? 0. So my range, the smallest value, and is it equal at 0? Does it equal 0 there? The answer is yes. So you use a bracket when it equals 0. But then with infinities, it always has to be a parenthesis. So my range is from 0 to positive infinity. Question? So if you look, and actually it's always going to come from your vertex, but the smallest y value in this case, this point on the y-axis is at 0. Okay? And then everything else gets bigger. And so the smallest value on this graph is at 0 on the y-axis, and then everything else, it goes to positive infinity. So you're always looking at the smallest value because you want to go smallest to largest. Now, how could you write that in inequality notation? Inequalities are greater than, less than, that kind of stuff. What do you think? Y, do you think it's going to be y is greater than or equal to, or less than or equal to? Greater than or equal to, because if you notice, this one is the smallest one and the graph is going up, so y is greater than or equal to what value? 0. So that is inequality notation. We're going to do it in our notes just to make sure you understand both ways, but on your homework you can choose to do it one way or the other, or whatever the directions say. I can't remember. Okay, so next one. The two things we need are our vertex and our a value. So in your groups right now, you don't have to graph it yet. I want you to try to see if you can figure out what is the vertex on this one and what is the a value on this one. So talk to each other, discuss it.
has right, and God does have it right, but when it does put the says it just don't teach you why it just make it very quickly, because like they started with these two topics that on deserts, but this is just the starting point.
All right, so do you guys think you have it right? Okay, so what's my vertex? What is the x value of the vertex? 0 is correct. Now, I want to, for those of you that maybe don't understand everything, the ones that are sometimes easiest to figure out is your a value is always in front. So what is my a value? 3, okay? And specifically 3 over 1. So that 3 is not any part of the vertex. Okay, that only has to do with your A, and the A is only telling you your width and also your direction. The number here at the end that doesn't have an X with it, that's always the Y value of your vertex. So therefore my Y value of the vertex is -1. Now if you look at the X squared, do you see how nothing's being added or subtracted in parentheses there? So if that's the case, then that means that the X value of your vertex is 0. Okay? So when we plot this, we're going to go 0 on the X and then down 1 on the Y. So I make my first point. So remember how I said think of this as slope, as rise over run? So that means from this point, I'm going to go where? Up 3, right 1, and up 3 and left 1. So did this make a narrow or wide graph? Very good. Okay, so hopefully you remember domain. What will be my domain? Domain on all of them is your x values, and it's going to be -infinity to +infinity, or all reals. The range is what's a little bit different, so you're looking at your y values. Okay, so how would I write my range in interval notation?
Y is greater or equal to -1.
Okay, so that y is greater than or equal to -1. Good, that's inequality notation. And then how do I write it in interval notation? What's the smallest y value? -1. And it equals -1, so we do a bracket at -1, comma, and then it's going to +infinity in a parentheses. Very good. All right, I want you guys to try that last one there on your own. See what happens.
So you guys have the A line, right? Because it's track. And then what you do is you go like
Okay. So normally I'm going to end up at some point, probably soon, I'm going to have popsicle sticks where I'm going to call on you to help me out. But today I'm just going to let you guys continue to share out. So vertex. What will be my vertex on this problem? 2, 5. So again, remember the x value of the vertex is what is with the x, whatever's in parentheses when it comes out as the opposite. So -2 will end up changing to +2. The y value is the value that is at the end, and it's a +5, therefore it is +5. What is my a value on this problem? Good, -1/4, and that's already written as a fraction. Which way, which direction is this one going to end up curving? Down, very good. And is this one going to be narrow or wide? Wide, good. So we go to graph this. We're going to go right 1, 2, and up 1, 2, 3, 4, 5. And this even tells me my direction. We're going down 1 and right 1, 2, 3, 4. Down 1 and left 1, 2, 3, 4. Okay, domain and range. Did you guys already do domain and range? Okay, what will the domain be and what's it going to be on all parabolas?
Negative.
Good, negative infinity to positive infinity. And the range.
Y is
Less than or equal to 5. And if you notice, that value is always the y of the vertex, because the vertex is always telling you it's either your maximum point or your minimum point. Okay? So that value for this is always going to come from your vertex, because that is a maximum or minimum point. Now, how do I write this one in interval notation? And this one is like slightly tricky maybe if you're not thinking about it right, but we always go smallest value to biggest. So what's the smallest value?
Negative infinity.
Very good. So our smallest value is negative infinity. So we start with the parenthesis from negative infinity, and then it goes up to our highest value, which is 5. Okay. Is there any questions so far? Anything that is a little confusing that you want me to talk about? Yes. So the x in the vertex always comes from here, okay? And we would go like x minus 2 equals 0, and you add 2 to both sides, and you get x equals 2. So a lot of times we just remember, oh, whatever's in there, whatever sign it is, it'll end up becoming the opposite of that sign. So on this one right here, that's what you're talking about? So we got less than or equal to because see how the graph is going down? It's going to be less than or equal to. If the graph is going up, it's going to be greater than or equal to. And right here, this value right here, that is your largest y value. And so this value is at your vertex, which is why it always comes from there. And so y is less than or equal to 5 is your range because it's at 5 and everything else in the graph is smaller than that. Where if it's going up, it would be greater than. Does anybody else have questions? Okay, moving on then. Okay, so this next part, they want us to write the function given this information. Now, if you notice, there are 3 points on here, aren't there? Whenever you're graphing a function, you need to know the vertex and your a value. This is the same for writing the quadratic functions. You need to know your vertex and your a value. So what is my vertex? Negative 2, 0 is correct. My a value, again, rise over run, is what? Very good, 2 over 1, but we'll end up simplifying that to just be 2. Okay, so when I'm writing this equation, and since they're saying quadratic function, we maybe could use f of x. If you write y, that's also fine, that's up to you. I'm going to go ahead and write f of x equals, and then what will I put next? 2, because you need your a value. Then what? Okay, so we're going to have parentheses, and it's going to be x plus 2. Why is it plus 2? Because it's always going to be opposite. So if this is minus 2 here, we need it to be plus 2 in here so that when it comes out, it would be minus 2, right? And then what should I add at the end? It's 0, right? Do I need to write plus 0? No. If you write it, it's not wrong, but normally you wouldn't see a plus 0. It would just be like this. So this is my equation. Okay, I'm gonna have you try the next one on your own. So before you try it, do you guys have questions about this one or anything you're not sure about how I got certain numbers? Yes. So quadratic functions are always written as y equals x squared. So if you have a parenthesis, you're always going to square it. If you have like a 0 value for your x, then you'll just have x squared. So in order to make a parabola, it has to have an x squared. The reason why, if you want more information, is remember that they're symmetrical. And so if I were to plug in, let's say, -1 into an equation, when you square it, you get like the same y values. So for every x value, you end up getting, or sorry, for every y value, you can end up getting 2 different x's. Will give you the same y answer. Okay, no other questions right now? Yes. So remember that in the parentheses, the x value of the vertex goes with that. And so the x value of my vertex, since it's -2, in order to get this to be -2, you need a +2 inside. So let's say if this had been -3, I would have had a +3. Okay? If it was 0 here, I would have just had x squared because there would be nothing adding or subtracting with that. Yes?
You always square it?
Yes.
Why?
So that's what we're talking about. Parabolas are always x squared, like y equals x squared. And so your x is always squared, and the reason is that if I were to take -1 and square it, I'd get a +1. But if I were to take +1 and square it, I'd also get +1. And so remember how we talked about how x values are inputs and y's are outputs? So there's 2 x values that will give me the same y output. And so parabolas are always symmetrical, where you'll end up having 2 points at like the same spot on the opposite sides. Does that make it more clear? Maybe not. Do we have more questions about this? Okay, try doing this one and then check in your groups, and I'll walk around to see what you got. Anybody have the answers yet?
Oh,
I just put -2, but it's
Perfect. Okay, so check the rest of your group. Okay, you got it. So check the rest of your group. Perfect. Check the rest of your group. We got the same
First week should not feel this dreading. So like I should have a and our Spanish class, we don't have real chairs. Or pull-out chairs.
I kind of remember this was from the next, or at least how I
You already had
it was like this, and so your whole point
I can't, I need one more back.
is it all easier.
And they can describe anybody about yourself. Because I put funny, stupid, I put tall, short.
Except for your
Down one, because you're too. I'm not blonde.
So that'll be that, and then
We should have taken German.
Yeah,
German high.
Oh, your test.
Okay. All right, I think I made it to every group. All right, most of you got it. Great job. So, again, we always want 2 pieces of information, our vertex and our a value. Vertex, the x value is at 1, and the y value was at 3. Remember that we're doing rise over run for our a, and so this went down 1. When you're going down, that's a -1, and then it went right 2, so -1/2. when I plug this in my equation, yes.
So if the problem is facing down, you always face down.
Yep. It's still rise over run. So rise meaning up and down, like standing up, sitting down.
Like if you flipped it around.
Okay. And then we have, equation f of x equals negative 1/2, and this will be x what?
X minus 1.
Good, x minus 1 squared plus 3. Do we have any questions for this graph? Okay, moving on. So now we're going to talk about reflections and transformations. So this is going to be my number 1 graph, and then this second one will be my number 2 graph. Okay, so when we're looking here with my original equation, f of x, what is my vertex? We need to know our vertex always, and my a value. So what is my vertex for this function?
One. Oh no, that's A. X squared.
So what is being added or subtracted with the x squared? Very good, 0 is correct. And then what is my y value? Negative 1 is correct. And what is my a value? What's in front? 1 over 1, perfect. So we're going to go ahead and plot this. 0, negative 1 means I'm going to end up going down 1. From my vertex, I'm going up 1, right 1, and up 1, left 1. And making our curve. Okay, now for our number 2 graph. What happens when we have negative f of x?
It'll go down like a pound.
Somebody said it. It reflects over the x-axis. Do you guys remember back in Math 2, what do you do when something's reflecting over the x-axis? So you know we're like taking this graph and then we're like flipping it almost. How do I reflect it? You'll end up going down 1 over 1, that's right. But where's my vertex gonna go?
Positive 1.
Positive 1, good. So see how it's 1 away from here? It's gonna go 1 away from here. Now, these other points, do you see how if we do 1 over 1, down 1, right 1, it's still in the same spot. So this reflects over like this. And for the fun of it, let's go ahead and put it into our graphing equation here. So this problem was x squared minus 1, right? And then what did it ask us to do? Negative f of x, right? So we'll put a negative in front. And you guys see, so did we do it right? Yeah? Cool. So do you see how like you trying to do it on your own, but then maybe plugging it into this program to double check your work is kind of helpful? Yeah? Okay. All right, next one. So g of x, what is my vertex for g of x? Tell me again, I heard somebody say it. 1, comma 2, very good. And what is my a value on this one? Good, and as a fraction we put it over 1. Good. So we go right 1, up 2. Am I going too fast? And then from there I'm going to go where? Good, up 1, right 1, and up 1, left 1. And we draw our parabola. Yes? Okay, so the vertex, remember that the first number is your x. So for the vertex right here, we go right 1, and then up 2. And then we did the a was up 1, right 1. Are we okay now to that? All right. Okay, does anybody else have questions so far on this one? Okay, so do you remember we talked about the beginning, but g of negative x, what's going to happen when we have the negative inside the parentheses like that? It reflects over the y-axis. So if something, remember when something was reflecting over the x, I went to so this is my x-axis. So this point on the x-axis, since it was 1 away from the x, I went 1 away up here. So here on the y, we're going to reflect over our y-axis, and this is our y-axis, correct? So what's going to happen to this point? Where is it going to go? Good, it's going to go left 2. It's really reflecting over the y, because see how here it's 1 away from the y? So we keep it 1 away from the y. Where do you think your other points are going to go? Good. Yeah, some of you are saying this. So see how this one is 2 away from the y? So I'm going to keep that one 2 away from the y. Now this one that's on the y, it's going to just stay there, right? Okay. And then that is your next parabola. And for fun, we are going to go ahead and put it into our graphing equation to double check our work. And so my original equation here is x minus 1 so there's my original, and then we're going to put the negative inside, and again you can see that's exactly what happened, how it shifted. Okay? Alright. Okay. Moving down. Okay, so this one, we're going to graph the function, and they want us to describe the transformation. Okay, so starting with f of x, what 2 things do we need to know in order to graph quadratic functions? Good, your vertex and your a value. So on f of x, what's my vertex? Good. 3, negative 1. What is my a value? 1 over 3 is correct. Okay, you go ahead and plot that real quick, and then we'll make sure you did that right. Okay, so you should have gone for your vertex right 3, 1, 2, 3, down 1. And then for your a value, it's up 1, right 1, 2, 3, and up 1, left 1, 2, 3. And you have your curve. Okay, so now we're going to move on to g of x. So again, I need to know my vertex and my a value. So looking at g of x, what is my vertex? So what's with the x? Zero. What's going to be the y value of the vertex? And my a value is negative 1/3. So remember that front number has nothing to do with my vertex. And then whatever's with the x gives us the x value of the vertex. Whatever's at the end is our y. Okay, so let's go ahead and plot this. So we have 0, 5. So where do we go? Up 5, good. 1, 2, 3, 4, 5. And then from there, my slope, I'm going to go down 1, right 1, 2, 3, or down 1, left 1, 2, 3. So how will I write this, like what happened from one graph to the other? So talking in terms of moving things right or left, reflecting over the X or reflecting over the Y. What happened back here on this example? What did they do? It reflected over the, no, this one reflected over the x-axis. So if you're ever flipping a parabola, it's going to have to, what? So if it's going from going up to going down like this, in order to make it flip over, it has to reflect over the x-axis, okay? And so the first part of my translation is that it is reflecting over the x-axis. If you do a big R like this and then you say x-axis, that's kind of how you can abbreviate. But if you want to write out reflect, that's also fine. Okay, I just like to abbreviate if I can. So once it reflects over the x-axis, this point would go from where to where? 3, 1. Do you guys agree that it would go from here because it's 1 away from the X to going to here? Yes? And then now we've reflected it, so it's like going down like this now, right? Okay, now I'm still not at the correct point. So what's going to happen now? Very good. And this is what we can do for translating. So we're going to go translating a T, okay? And then you always do X first and then Y. So X right and left values. This would go left 1, 2, 3. So I'd go -3, comma, and then it's going which way? It's going positive 1, 2, 3, 4. Okay, but if you want to write instead of this, if you just write left 3, up 4, that also works. But you'll also see it like this. Just remember, these always go in order. X and Y, your left and right value comes first, and then your up and down value comes second. Okay, so this is basically my answer. Okay, what do I need to explain any of that again? So in order to change something from going up, positive, to making it go down, it has to do what? It has to reflect over the x-axis, okay? And then from there, you can translate it, correct? Okay. Last one, number 9. Write and graph an equation of a parabola that opens up. So this is important. It's telling you that it opens up. It passes through the lattice point, the heart. So it has to pass through the heart, but avoids the wall. And the wall is a line segment. So if you look right here, here is your wall. Here is your heart. And in case you can't really see the lines very good, this is like your X and Y axis. Okay, so as you can see, this is kind of playing into our performance task that we're going to have towards the end of this unit, okay? I find that it's easiest to start at like the lowest point on the graph. And so in this case, since they want us to open up, if I start at my lowest point on the graph that they want us to go through, it is the heart, okay? Now, I can't touch this wall. So I need to make a curve going up, but it can't touch the wall. So I know that I'm going to probably want to point at least there. So this is my vertex, the heart, and see how this is going up 1 and then right 1, 2, 3, or up 1 and left 1, 2, 3. Do you see how that parabola can miss the wall but it hits the heart? Yeah? Okay, so now you have to write that function. Okay? When you're writing a function, we need to know the vertex and the A value. What is my vertex? Vertex is 4, 0. What would be my A value for this one? Good. 1 over 3. Now, if I had say, let's put 1 over 4, would that have also worked? Yeah, because I could do 1 over 4 and it'd be an even wider graph. It would still not hit that wall, right, and cross through the heart. And so there's always going to be more than one answer, but we're just going to do one in the notes right now. So how will we end up writing this equation? What number will go in front? Good. 1/3. Will I need to use parentheses on this one? Yes, and it'll be what inside the parentheses? Good. X minus 4, and don't forget your squared because that's what makes it a parabola. And then do I need to put anything at the end? No. So that would be the equation. Do we have questions?